Hello students, now today we will discuss squares and rectangles in a size 9 by 6. See, we have a rectangular box and its size is 9 by 6. It is 9, this one is 9 and this is 6. We will write here this is 9 and this is 6. So this is 9 and it is 6. So this is a rectangular box. In that I have to make squares and rectangles, means we have to determine number of rectangles first, number of squares, and third is rectangles. Number of rectangles, those are not square. In previous video also we took a chessboard. In that also we calculated number of rectangles, squares and this. Rectangles, those are not squares. So here three things are there: number of rectangles, number of squares and number of rectangles. Those are not square. And all of you know square means dimensions are same. Rectangle dimensions are different. And also these included there, so dimensions will also be same. So we require all rectangles, those are rectangles and squares. Only squares. And third one is number of rectangles, those are not square. Okay. So see, this is 9 and it is 6. This is 9 and it is 6. 9 and 6. This is 9 and it is 6. So in that we will make rectangles. First we will make rectangles and then in that rectangles we will find squares. And if we find number of rectangles and if we subtract number of squares in that, we will get the third question. Number of rectangles, those are not square. So the size is there 9 by 6. Okay student. So this is bigger size. For understanding, I will take one smaller size. So if I take, see this, if I take like this is 3 or like this is 2, 3 by 2. So you can easily understand how many rectangles you can make in that and how many squares in that. So this is 3. So number of rectangles you can make, like size is 3 by 2. That bigger one is 3 by 2. Okay, 3 and this is 2. 3, 2. And after that, if you make, this is 3, this is 2. And keeping this 3 makes, you can make 3 by 1. This is 3 and you can take 3 by 1. This is 3 by 1. So if the length is 3, you can take width as either 2 or either 1. So 3 by 2, this is only one rectangle. In that circle I am writing number of rectangle, it is 1. And in that 3 by 1, 3 by 1. So 3 by 1, see this is 3. So 1 is this like, see 3 by 1 and another this one. If you divide this, so it is 1, 3 by 1 rectangle and 3 by 1 rectangle. So these are how many rectangles are there? This is 1 and it is 1. So it is 2. Okay. So this is 3 by 2 and 3 by 1. Now I will reduce this length 3. If you take 2 by 2, 2 by 2. So now see, this is 2 and this is also 2. If you take 2, reduce here, it is 2, it is 2. So 2 by 2, this one 2 by 2. If you leave there, so this is 2, this is 2. But if you leave this part, it is also 2, it is also 2. So 2 by 2 you will get 2 rectangles. Size is 2 by 2. So this is square, but we determining this one number of rectangles. So 3 by 2 is 1, 3 by 1 is 2, 2 by 2. Another size is there 2 by 1. Another size is 2 by 1. So 2 by 1 means this keeping this length 2 fixed. So 2 by 1 means this is 3. If you take this one is 2, this is 2. So 2 by 1 is 2 by 1. This one. Now if I write there, this is 2, this is 1. 1 rectangle. Another is this. If you see my movement of my fingers, it is again 2 by 1. So these two. Now if you leave there, it is 2 by 1. See, this is 2, this is 1, and another is this 2 by 1. So how many are there? 1, 2, this one, and this one. It is 4. Now we reduce the length 3, then 2, then the next length would be 1. Length is 1. Okay, students. So length is 1. So by 1 you can make how many rectangles? 1 by 2, bigger one, and 1 by 1 is a smaller one. Okay, so 1 by 1 is, now see 1, if you take 1 by 2, it is 1 by 2, 1 by 2, and 1 by 2. If I draw these vertical lines, it is 1, it is 2, 1 by 2, 1 by 2, and 1 by 2. So how many are there? 1, 2, 3. And 1 by 1, if I write this one, if you draw this, it is 1 by 1, 1 by 1, 1 by 1. So that is simple. It is 2 into 3, it is 6. So number of rectangles are there. If you add these all, 1, 2, plus 2, 4, plus 3, 6. So it is 3, 6 and 9. 3 plus 6 plus 9. So it is 18. So total rectangles are there 18. Now how many squares are there? You can see here in 3 size. This is 3 by 2 size, this is 3 by 1, no square, 2 by 2 and 1 by 1. So these are rectangles. Now squares, these thing 2 plus 6, it is 8. So rectangle excluding square, it is 18 minus 8, that is 10. So here I took a smaller size. So that is easily to visualize how many squares are there and how many rectangles are there. But in that we will discuss. See, now we have 9 by 6. Size is 9 by 6. Now I will develop a skill in that. I will develop a skill how to determine squares and rectangles. See, you have to observe movement of my fingers. This is 9 and it is 6. So in that 9 by 6, 9 length is fixed and we will reduce the width 6. Now 6 to 5, now 4, it is 3, then 2, then it is 1. Means rectangles in 9 by 6, then 9 by 5, 4, 3, 2, 1. Okay, so 9 by 6 only we will get one rectangle. So here I am writing number of rectangles, it is 1. And now see 9 by 5. 9 by 5. Okay, 9 by 5. If you think 9 by 5, it is 9. And here it is 6. So you can take like this. This is 9 and this is 5. 9 and it is 5. So 9 by 5 is 1. And if you leave this part, see the movement of fingers. This, if you leave this part, then lower part is 5 and length is fixed 9. So 9 by 5. And this one is also, if you leave this, it is 9 by 5. So here you will get two rectangles. Similar process 9 by 4. See this 9, keeping 9 fixed. If you want to make this length as 4, so there are 3 ways. This is 4, leave this is again 4, and this one is also 4. See, if you leave this is this thing 2 units. If you leave, so this thing is 4. Okay, and now if you leave this thing, so this one, that top length, this one is 4. And one more way is there. If you leave this below and this bottom and top, 1 unit and 1 unit, so this also 4. So by 6 you will get 4 width, like 3 ways. Leave this one or 2 here or 2 here. So these are 3 rectangles. So here you can say this is 1, this is 2. By this trend you can develop a formula. It is 1, this is 2, this is 3, this is 4, this is 5, and 9 by 1, 9 by 1. See, 9 by 1, 9 by 1, 9 by 1, 9 by 1, and 9 by 1. So total 6 rectangles are there. So by that, again, if I reduce this as 8 by 5, 8 by 4, 8 by 3, 8 by 2, 8 by 1. See, 8 by 6. Now we will develop a formula for that. 8 by 6. See, this is 9. So 8 is like, if you leave there 1 unit, so it is 8 by 6. 8 by 6. See the moment. This thing you leave. So this one is 8 and this is 6. 8 and 6. So 1. And here if you leave, then this is 8 and it is 6. So this is 2. Okay students, now 8 by 5. Again I am explaining, this is 9. So 8 is there. If you take this thing out, it is 8 by 5. So here 6 is there. So you can take this as 1 unit less. So 8 by 5. 8 by 5, 1. See there is movement. This is 5, this is 8, 1. If you take there, this is 8, this is 5, 2. And again here also it is 8, it is 5, it is 8 and it is 5. So total here is 4. Now see, this is 2, this is 4. Now see the trend. 1, 2, 3. Double of 1 is 2. Double of 2 is 4. So it will be 6, 8. See, this is 2, this is 4. This one be, see, I am explaining again how many are there. 8 by 4. See, 8 by 4. So this is 8. Again, if you leave this part, it is 8. And here, this is 6. And now we require 4. So 8 by 4, keeping this as 8. Keeping this as 8. Now 4. If you take this 4, 1, then leave 1 part, then 4, then leave 2 part, then 4. And also if you leave 1 and 1 part, now see, you will get 4 rectangles like this. See, anyone can understand this is 8. If you take this as 4, so 1 rectangle. Then if you leave 1 part, again it is, and if you leave 2 parts, the bottom part is 4 unit, it is. And if you leave 1 and 1, 1 in top, 1 is bottom, again it is 4, so 4 rectangles. Here I leave this part. If I leave this, the same process is repeated. So total 4 plus 4 is 8. Total it is, total double of that, and 8 by 5, total 8 by 5 is this 2, and total 8 by 5 is 4. Now see this one, 8 by 4. 8 by 4, I am explaining again, it is 8 and 4 we require. So this is 4, 1 rectangle. See this movement, this is 8 and this is 4. If you leave 1 part and it is like this. This is 4. See this. Second. And now see, after that, if you leave one part, then another one part, this one, so this is also 4. So these are three rectangles are there. If you leave one part, then one part, if you leave this part, so one rectangle. If you leave this part, another rectangle, and if you leave one and one, so this is another rectangle. So how many are there? 3 rectangles here and 3 here. If you leave this is 6. So now you can see the trend double. It is double of that line, 2, 4, 6. It is 8, double of that and double of that. Now we can develop a scale. Now 8 by 6, reduced size is 7 by 6, 7 by 5, 4, 3, 2, 1. Now see, 1, 2, this is 3, double of that, double. Now it is triple. So 7 by 6. Now see, if you want to determine 7 by 6, 7 by 6, 7, here if you take 7 and 6 whole length, so it is 7. Taking this, you leave this is 7 by 6. Okay, so 2 unit here. If you take 2 unit there, also 7 by 6, and 1 unit there, also you will get 7 by 6. So this is 3. This is 3. Now see, this is 3. Now 7 by 5. And again visualize this 7 by 5. So it is 7. If you leave this 2 part, this is 7, and 5, for 5, this one is 5, 1. See the movement of fingers, 7 by 5 and 7 by 5, and again leave this part, so it is 7 by 5, and these are 2, and they are also, you will get the same. See the 7 by 6, if I make this, leave these 2, this is 7, this is 7, and this one is 5. See, if I make this is 7 by 5, like this. Now if you take this part, not this one, so it is again, this is 7 by 5, this one is also 7 by 5. See the 7 by 5, this is now 5, it is 7, 2 units is not taken, so this is 5, this is 7. Now if you take this part, now if I make this like this, 7 by 5, see this, 2. So here you are getting 2 rectangles in that, and also this, if you take 9, this is 2, and if you leave there 2 units, similar process there, so 2 plus 2, 4, and if you not take one part here and one part here, so again you will get 2 rectangles, so total is 6. So you can easily see the trend. This is 1, 2, 3, 4, 5, 6. These are double of that. These are triple of that. Triple. 1, 2, 3. 3, 6, 9, 12, 15, 18. Like that. So size is reduced. Then we will get 7 by 6, 6 by 6, 5 by 6 size. 6 by 6, 5 by 6, 4 by 6, then 3 by 6, 2 by 6, and 1 by 6. So size is reduced to 9, then 8 length, then 7, 6, 5, 4, 3, 2, 1. And now I am not writing that. This is 6 by 6, this is 6 by 5, and this one is reduced to 6 by 1. And also 5 by 6, 5 by 5, 5 by 4, 6 by 4, 5 by 3, 5 by 2, 5 by 1. Similar for these 4 by 1, last one, 3 by 1, 2 by 1, and it is 1 by 1. Now see the trend in that this is triple, in that this one is 4 times. 4 times that, 4, 8, this is 5 times, 5, 10, 15, and this one is 6 times. 6, 12, 7 times, 8 times, and 9 times. Now see how many rectangles are there. I am writing here number of rectangles equals. See, in that first line we are getting 1, 2, 6. 1, 2, 3, 4, 5, 6. For second line, double of that, it is 2 times 1 to 6. In triple, 1 to 6. 4 times, this is 1 to 6. 1 time, it is 2 times, same thing, 3 times. So last one is 9 times. So this is 9 times 6. So that bracket is same in all. You can take this common 1 to 6, and this quantity outside the bracket, it is 1 to 9. Okay, so this is sigma n. All of you know sigma n, sum of n natural numbers starting from 1 is n plus 1 by 2. So if you add this 6 into n plus 1 upon 2, it is 9 into 1, 10 by 2. So that is 60, 15, 9 is 135, 135 into 7. Okay, so here it is 2 5 ja, 2 3 ja, it is 21 into 45, 21, 945. So number of such rectangles are 945. So here one trend is developed by this. First you have to find the number of rectangles by this way only. Okay, and if you have any doubt in that, in comment section you will comment on that. I will explain in that. Okay students, so these are 945, these are 945. Okay, so one skill is developed in that. See, 1 to 6, our size is 9 by 6, so this one is 1 to 6, and that 9 is 1 to 9. Means we can say if a rectangle is there, rectangular size is there, n by p, or n is greater than p, means n is length and p is width, then number of rectangles, so it is very good concept, number of rectangles sigma n into sigma p, that is 1 to n sum, n plus 1 by 2 and p plus 1 by 2, so that is np by 4, n plus 1 and p plus 1. So if you know this and this rule, by observation we got this rule. Means whenever scientists make rules, they will do the same thing like that. So we have the size 9 by 6, so that is 9, n is 9, it is 6, 9 1 10, it is 6 1 7 upon 4. So that is 2 2 ja, 2 5 ja, 2 3 ja, 21 into 45 is same 945. Okay students, so number of rectangles are 945. Now one more thing is there, so here it is 945. Means size is different, so it is 945. Maybe you will got all the things. Means I made this by reducing the length and width. Means see, the length, maximum length is 9 by 6 and lowest length is 1 by 1. See this, 1 by 1. This is maximum 9 by 6. Okay, sometimes they ask how many rectangles are there. Bigger rectangle sizes 9 by 6. Smaller rectangle sizes 1 by 1. That is a square. Okay, so now we will get how many squares are there. See, if the length and width are different, those are not squares. So these are in that line, in that size, there is no square, in this also no square, in this also no. But when n equals to p. This is n is greater than p. We took when n and p are same, means smaller is p, greater is n. If n becomes p, when n becomes p, here 6 by 6. So we will get square 6 by 6 size, then 5 by 5. See here, it is 4 by 4. It is 3 by 6, 3 by 5, 3 by 4. This is 3 by 3. If you want to write, you can write all these. So it is, see this 6 by 6, 5 by 5, 4 by 4, 3 by 3. This is 2 by 2 and it is 1 by 1. See diagonally from this, it is, these are the rectangles. 6 by 6, 5 by 5, 4 by 4, 3 by 3, 2 by 2 and 1 by 1. So number of rectangles are there 945. Now we will calculate number of squares. It is, see this, means first rectangle when square, first rectangle is square when n and p are same. Here we are getting 4 squares. 4, then 10. See this trend, 4, then 10. In that line 6, 6 double 12, double of that is 18. So number of squares. So we will calculate this number of squares. Number of squares in that this is 4. This is 4. Now see in this is 10. Now it is 18. 4, 10, 18. Now see this line start with 7. You can write the table of 7. 7 3 14, 7 3 21 and 7 4 ja. See fourth line. This is 1, 2, 3, fourth line. So it is 4 1 ja. Fifth line. So 5 2 ja. Sixth line. So 6 3 ja. Seventh line. So 7 4 ja. Eighth line. So 8th line, that is fifth term, so 8 5 ja, and ninth line it is that. So this is 4, this is 10, this is 18. Now see this one is 7, 7 to the 14, 7 3 ja 21, 7 4 ja 28. By special sequence you can observe this is 4, 6 is added, 10, then 8 is added, 18, then 8 is added, then 10 is added. Okay, now see this 6 is added, 8 is added, 10 is added. Now 6, 8, 10. Now how many will be added? 12. So it is 40. Now see here also it is represented 8. Now this is the table of 8. 8 1 ja 8, 8 2 ja 8, 3 ja 8, 4 ja 8, 5 ja 40. Differences of 12. Again it is 12 difference, 14 difference. 14 difference is 54. See here 9 1 ja 9, 9 times of this one. So this is sixth part. 9 6 are 54. So if you add these, easily you can add. See this 18, 28, 28 plus 18, 28 plus 18, 46. 28 plus 18, 46 plus 4, 50. 60, 100, and it is 154. So number of squares, number of rectangles, not square, excluding squares. So this is the important part of this question. It is, so we calculated there, it is 945 minus squares. If you subtract it, you will get 791. So you will get 791. Okay students, so here one trend is developed. For that means any square is there, any rectangle is there, any size is there, you can make like this. But in exam you can't like this. You can make like this. So easily you can understand, your examiner will also understand these all things. So, or otherwise you will, if you forgot all the things, you can make such type of problem with less dimensions, means 9 by 6 is given. Initially I gave 3 by 2. You can take at home 4 by 3, 4 by 2 size and make the rectangles. I am writing here, you can make 4 by 2 rectangle and squares, and comment section you can write the answers also. Okay, so this is 791. So that one you easily understand. This came from this formula, means any size is there, 9 by 6, you can easily make this 945. For that also you can make formula. Okay, so this is 791. Squares started from this 4. Squares starting from 4. This is the fourth line, 9, 8, 7, 6. Fourth line, first term. Fifth line, second term. Fourth line, first term. Fifth line, second term. Then third, fourth, fifth, and sixth. You can make the formula for that 154 also. Means you have these 9 and P. 9 is N, P is 6. So first square you got by this 4. So see this 4. I am making one trend. See, 9 minus 6 plus 1. See, this is the fourth line. We have the size 9 and 6. 9 minus 6. 3 plus 1. It is 4. See, first line, second line, third line, and fourth line. 9 minus 6 plus 1. Fourth line and first term. So it is 4 into 1. Fifth line. Second element we are getting from fifth line. See the thing. First, second, third, fourth, fifth line, second element. So fifth line means 9 minus 6 plus 2. And this is the second element. So multiply this thing. 9 minus 6 plus 1 by 1. 9 minus 6 plus 2 by 2. See this. 3 plus 2, 5, 2 the 10. Second element. See, anyone can understand this. 4 then 10. Now see, this one is fifth. Now see, sixth line. This is the sixth line number. 9 minus 6 plus 3. This is 3 plus 3, 6. So in that we are getting, see, first, second, third, fourth, fifth, sixth line, and this is first element, this is second element. See, this is first element. First is this, second is this is third. 9 minus 6 plus 3 into 2. See, 9 minus 6 is 3, 3 plus 3 is 6, 6 to the 12. So here it is, for sixth line it is 6 by 6 line, 6 by 6, 5 by 6, then 4 by 4, 4 by 4. So it is, for 4 by 4, it is 3. See this 3. So it is this 18. For seventh line we have 9 minus 6 plus 4. It is 1, 2, 3, 4. 9 minus 6 plus 4 into 4. It is 8th line, 9 minus 6 plus 1, 2, 3, 4. It is 5. So 9 minus 6 plus 5 into 5. So it is 3, 5, 8, 8, 5, 40. And again that one is 9. It is 9 minus 6 plus 5. So it is 6. 9 minus 6 plus 6 into 6. So it is 9 6 are 54. So here one trend is developed. This, see the 9 minus 6, 9 minus 6, 9 minus 6. It is n minus p. So number of squares are there. Squares are there. N minus p. That is fixed. Difference is fixed. That thing is variable. So here you can use sigma representation. 9 minus 6, it is 1, 2, 3, 4, 5, 6. Variable is represented by r, and it is also same here, 1 to 1, then 1, then it is also 1, 2, then 2, 3, then 3, 4, then 4, 5, then 5, 6, then 6. So it is r. So, and r value varies from 1 to 6. Minimum r is 1 and maximum r is 6. Maximum r is 2p only. Maximum r is from 1 to 6. See this, 1 to 6. 6 is n minus p. 6 is n minus p. Only n minus p maximum. So n minus p is fixed. This is, you can write this as 9 minus 6. 9 minus 6 is 3 plus r into r. Sigma r equal 1 to n minus p. You can write this formula 6. So it is 3r, 3 sigma r 1 to 6 plus sigma r square r equal 1 to 6. So now it is 3 r plus 1 by 2, then 6 plus 1 7 by 2 plus sigma n square. I am writing here sigma n square is n plus 1 2n plus 1 by 6. So it is 6, then this is 6 7 double of 6 12 plus 1 13 upon 6. So it is 2 3 are 6, 3 3 are 9, 9 7 are 63. And this is cancelled, that is 91, that is 4, and see the miracle, it is 154. Here we counted all, this is counting without counting. So it is 154. So the number of rectangles whose are not squares are 944 minus 154. That same thing I wrote, it is 795, 791. Okay, so again I am explaining these. I reduce the length and one by one we visualize how many rectangles will be made. Then in that, see from here, these are the squares. So easily you can count. Otherwise, one trend is there, n minus p is fixed. This is r varies from 1 to n minus p, and easily you can calculate this is 791. So these are the number of squares which are not rectangle. So okay students, I discussed this problem. This is most important problem for exam point of view. You can easily understand by this explanation, and also you can make squares and rectangle of some smaller size to develop your skill. So students, if you got all the things, you can like this channel also. If you find that this is interesting and knowledgeable and easy going, so you can like my channel and also share this channel, link of this, and also subscribe this. So next time we will discuss some more interesting problems of permutation and combination. Thank you.